just browsing around the repository and the app for a little bit. So kind of neat that you've got the different designs here. I feel like there's a lot more design of experiments pieces here, some that I don't recognize actually, which is kind of cool. Can learn about some additional ones. For the parameter ranges, I'm noticing you can just increase this, and you've got the float, integer, categorical. You also have linear inequality constraints that you can add. Can separate it with multiple commas. You can select the design type. Frankly, I might be missing something basic, but I'm not really sure how to produce the designs. Okay, gotcha. So it produces it in this tab, at which point you would download the CSV or Excel out of the Excel file. Okay. Okay, and I just opened that up. Notice, yeah, you've got just the variables and as columns, and then the run. It's like this run order thing. It's not showing, but there's like a run order column, which, right, just this one here, 1, 2, 7, 8, 6. So that's the, okay, random order. So you just shuffled the designs there. Now, assuming I stick with this initialization, then I go over to Bayesian optimization. That's where I'm saying, okay, here's the format. So that's the same sort of thing. So if I go and adjust, I can manually adjust the Excel spreadsheet just with some variables that I can't see right now, but I'm just going to add a bunch of random values, which obviously will lead to not much by way of modeling. Performance to, okay, I'm going to save that and upload it again. Okay, so these are just like the random responses I threw in there. Grabbed the factors, shows the response column, asks for defining, okay, essentially the same thing as before, like, is it a flow, integer, categorical, what's the min and max for these? And then we go, yeah, it's not something, maybe I just set this back to -1, 1. And I go up here to Bayesian optimization, and I want to, I'll just say, we want to minimize it. Okay, it looks like batch is supported, and then you can do Sol or Bayesopt. Okay. Yeah, so we already used Sol to generate the initialization candidates. And then fixed parameters. Oh, gotcha. So let's assume you're doing batch optimization, and okay, yeah, using a robot to make experiments with varying concentration but fixed temperature. Okay, so that makes sense. You could say, okay, the temperature is fixed to, I don't know, like 20 Celsius or something like that. I'll remove that. Linear constraints. Yeah, same thing. Yeah, and then just this note, nonlinear constraints, you transform columns, I guess. So you'd have, like, as one of your columns, x1 squared, x2 squared. Obviously that affects how the, how the search space is represented as well from a modeling perspective. Plot options. Okay, so you've got slice plots, which will just show the probably the average prediction. My guess is these are the same sort of slice plots you find in Axe. It's like predicted versus that one variable X, where the predicted is, or sorry, all the other parameters are probably set to the average, or maybe they're set to the best predicted one. Okay, then compute update model, since it's running. Okay, next experiment. So it suggested 2 experiments, and looks okay. Yeah, so it has the predicted response. Doesn't look like it has the predicted uncertainties by default, at least not here. And then best parameter. Maybe this is best in sample. Yeah, this must be best in sample prediction. If I go back to data loading, hopefully I don't lose out on the stuff. Data loading, find the one that's here. So it's saying, yeah, like I set it to minimize, and it's just saying out of everything that we have, this was the best observed. Though I'm not sure if by default best parameters would use the in-sample predictions or just the in-sample measurements. Kind of suggest in-sample measurements because it's not showing like predicted response for it. And then, yeah, so far I haven't really seen anything related to assumptions about noise. I think that's a huge issue. Also seems like there is the possibility of having something that's multi-objective, so multiple responses, as well as something that is not a metric. So if I go over to predictions, okay, gotcha. This is just saying if you want to make some predictions, you can for arbitrary pieces. I don't know if I need to. Oh, okay. It was like okay. So auto updates for that one. Nice. Again, I'm not seeing predicted uncertainty coming out of that, which in assuming Axe is under the hood here, you've got like best parameters or something like that. You'll end up with the mean and then a covariance matrix, and so and usually you just be looking at the diagonal. I think the square root of it. I have an issue or something related to that. Okay, so then you get next experiments perform. If I go here, it looks like, okay, download a CSV, show hide columns, search. Okay, so it looks like this is maybe some pandas or polars table being used, just with those are the default options. Plot model, update plots. Okay, so maybe that's updating on there. Oh, no, okay. So it updated down here. So we've got these mean and uncertainty. Oh, wait. Yeah, mean and standard error plots shows the candidates, shows the existing points. Also noticing this SEM none. In other words, you didn't specify the standard error. You're just letting PACS, I'm assuming, infer the standard error, infer the uncertainty. Okay, yeah, and so then you've got concentration versus temperature. You can change these ones around. Temperature, concentration. Nice, yeah, in sample candidates. for each of those. Okay. Yeah, then you got your trace plot, best objective versus, so best so far versus number of iterations. Since everything was, oh, let's see, 5. Okay, so just the way I randomly made up these. So I had the first one be 5, and then nothing was better than 5 until this last one where I just happened to put 1 in there. So that's what the best so far plot is showing. Looks like it only lets you show the best so far and not view the raw data here, which is like a user preference, if you will. One other random note I wanted to make was, hopefully I don't lose any of the data here, but if I go back to, where was it? Yeah, here we go. The app tells me to measure new points with a predicted outcome that's worse than what I already have in my database. This is nice, just kind of going through. The point is you're doing exploration and exploitation trade-offs, and we're trying to use the uncertainty to help us build a better model with the goal of eventually finding the best possible outcome and everything. So it's not a one-shot, not meant as a one-shot algorithm, but truly an optimization one where you're exploring and exploiting and trading off between those. So this was kind of a nice visualization for that process, how that goes through, showing the uncertainty getting reduced. Looks like this one assumes noise-free measurements, which usually makes it easier to teach about expected improvement or other ones like that. Other acquisition functions. Which is not going to be the same as, at least from what I can tell, from how the implementation is over here, because that standard error metric was showing as none, meaning Pax infers that for each of the points. Okay, so, okay. Looks like I did lose. Okay, yeah. So I lost the data from that, so I would have needed to have stored it. Okay. And then here, allow tuning optimization versus exploitation. So log EI, okay, that's nice. That's being used by default. Then this will switch to upper confidence bound. Nice, yeah, where oftentimes people are asking this, like, hey, how do I change the amount of exploration? Usually that's not, at least in my opinion, not always the best question to be asking. Is that you're embedding all sorts of bias and assumptions, and I think it's a lot easier to throw things off without really strategically and intelligently controlling for said exploration. But upper confidence bound is one that explicitly has a parameter you can change, this beta parameter. So that seems reasonable. If I change that, yeah, it's just giving you, hey, what do you want beta to be? And anywhere from -5 to 5. And so like this is one where it's so problem dependent, like what the optimal value of beta is, that I just worry sometimes people just end up kind of shooting themselves in the foot, making it suboptimal by trying to do this, like what physically what's 5 and -5 going to correspond to. But one way or another, people tend to ask for it. So seems reasonable to at least give an option for a different acquisition function. And if I'll go back here, compute, update model. Then nice, yeah, saying, okay, it's probabilistic, results may vary slightly each time you run it. You can kind of get this with setting a seed. I'm not sure if you really want to have a seed and kind of complicate things with that to get a little bit more deterministic behavior. But anyway, this. Oh, and then, okay, that's interesting. UCB only available for a single number of experiments. So by requesting two, so it looks like at the very least batch UCB isn't implemented. I don't know a ton about that one. About like batch UBC, or sorry, UCB. Okay. Though it did look like it still gave a result. Okay, if we go back to 1, okay, allow tuning, set to 2, and then compute update model. Which is interesting. It looks like it still gave 2 suggestions, even though it says it's only available for a single number of experiments, and it's actually grayed out if you select this and then change it from 1 to 2, it'll still let you suggest it and get 2 experiments. So anyway, but one thing to seems like maybe a bug to be addressed there. Yeah, this predicted response all seems fine. Then I'm assuming if I go to data analysis and modeling at the bottom, I'll wait for the plots to appear. Okay, so yeah, same thing there for the this one. Then data analysis and modeling. Okay, looks like I lost the file again. So if I go back, so like navigating between these leads to a loss of the uploaded file. I'll come back and just check out the multi-objective piece in a second. So let's go here, upload that same file that I had. Visual assessment. Okay, so you're getting QQ, box, histogram, scatter plots. Okay, yeah, so the scatter plot essentially, this is how you get the best so far trace, is you take a running minimum or running maximum, whatever it may be. Be interesting to see how this changes with a multi-objective setup. And then the QQ matching, this is just Brio. No. Yeah. Not sure if somewhere there's going to be a leave one out cross validation plot. Okay, Pearson correlation, pair plot. Okay, polynomial fits. Right. For each of them. So I guess this can kind of show you, is this a really simple relationship between this, or is it more complex and there's nonlinear components? Essentially, if this was like perfectly fitting a two kind of order of 2 polynomial fit, then probably pretty simple simple problem. But if not, then you're getting interactions and effects from other variables. One thing I'm not seeing here is a feature importance plot, which like inverse length scales. That would probably be nice to see, using like the things like get feature importances and then sticking that in some kind of plotly bar chart. It's kind of a nice way to go about that. Linear regression. Okay, so it's giving you Okay, predicted versus actual based on a linear regressor. You can then do predicted responses on a per point basis. Magnitude of effect. It'll be interesting to see how that one's being calculated under the hood. Negative, positive. Okay, ordinary least squares regression. So maybe under the hood it's a SciPy. Maybe it's SciPy. Then we go machine learning. Okay, got all sorts of models to choose from. So the descriptions for these. I go here to just say Gaussian process, and then we're doing. Okay, so it looks like it's only allowing for taking fractions from the validation set. Oh, sorry, realizing. Yeah, feature importances. I jumped ahead, jumped the gun a little bit. That's over here. It looks like it will plot feature importances here, and then also looks like it's not going to be cross-validation, but a single train test split. And then this says you can add additional parameters for the model. Okay, so it's letting you change things about the Gaussian process model, and then it's using same scikit-learn Gaussian process underneath the hood, which seems a little, it's a little bit interesting. That wasn't part of the Bayesian optimization one, which presumably was using AX and like AX's implementation of Gaussian process regression. Anyway, we'll go do that. And we get predicted versus actual for the Gaussian process regressor. R-squared test is actually a little bit frankly a bit odd, since I just threw in completely random values for the response. So I guess overfitting in that sense, maybe. Anyway, going down to Gaussian process model does not support feature importance. Probably inverse length scales would help there, but it's all right. Predict a response. So yeah, same thing, just kind of letting you change that dynamically. Then let's go to gradient boosting. I mentioned some probably good feature importances, or maybe not. Okay, let's. Oh yeah, okay, it's there. So it looks like there's a little message about it not being supported, but maybe that was left over from the Gaussian process piece. One or another generated the feature importances with some with the random state with the seed fixed, and yeah, this one's also showing like a. I'm not sure if this one would show like negative, positive effects. It just happens to all be positive in this case. I'm not really sure if it's using CHAP under the hood or something else. But anyway, yeah. So feature importances coming in here, as well as some uncertainty of those feature importances. Noting some predictive uncertainty, not like the uncertainty over multiple campaigns or runs, which is normally when I put uncertainty bars on the features. I guess in the context of inverse length scales, I don't know if there's some way to pull out, or if it would really be meaningful to pull out something for the variance, like the uncertainty of the optimized inverse length scale. But one way or another, seems fine. Just out of curiosity, if I do that for linear regression, then okay, yeah, we're still getting feature importances some way. So it'd be good to kind of know where those feature importances are coming from. I'm not sure if that's specified over here. Okay, looks like not so much. That's okay. Then kind of last thing, I think I'll go in and go back to maybe back to Bayesian optimization. I'll just add another response column. You won't be able to see this, but I'm just gonna copy over what I had for the first column, call the name response to, and then I'll just kind of like shift those values around a little bit, adding adding 5, subtracting 2, just making a little bit. So they'll be pretty highly correlated. At least given that there's a range, like a max of 54 that I was giving for the neutral one. I'll save that, upload it. Okay, so now we've got all these and response 2. You'll notice I just kind of shifted these, perturbed them slightly. Each of them. Oh, and it's recognizing this response as a variable, but I just need to add in response, I guess. Okay, so it's not clear to me how I would do multi. Oh, it was treated as a factor, so I gotcha. So I wouldn't be able to add as a response because it's already treated as a factor or tunable. Generally, I call this a parameter, but I guess they're choosing factor is the terminology here, which kind of goes back to design of experiments language. Back to Bayesian optimization, looks like it has put in 2 directions now, and say like minimize for both of these. Look like anything else is too different. While we're here, okay, it does look like you can specify multiple of the fixed parameters. Currently, I'm not seeing anything that would allow you to do featureization or add contextual variables. In other words, things that you maybe measure or can calculate, but aren't directly things that you can tune, or more of an advanced feature anyway, and then causes all sorts of issues when it comes to optimizing the acquisition function. If it's not differentiable, then you can use something like a genetic algorithm or do brute force methods. If it is differentiable, then it's a plumbing issue, but it can still be a kind of complex plumbing issue that comes from that, of trying to get it to kind of recognize these contextual variables, like still do normal gradient-based optimization of the acquisition function, but still have these like variables that weren't necessarily tunable variables. Okay, and then prediction. Okay, so I need to compute, update the model. So I guess another thing is if you're running this in kind of the human in the loop perspective, you want to make sure that you're updating your file. And once this goes through, make sure that you're like, I guess maybe downloading this as a CSV and updating your like updating your original Excel file. this suggested experiment and then the new one. Now, I guess one thing about this is that would let you put in a different value than, different set of input parameters than what was suggested if you so chose to. And I'll just kind of assuming that under the hood, how it's implementing that, it's doing justice to like skipping a syllable step and going straight to Bayesian optimization. Frankly, that might be why like an appealing point of having these completely separate, of saying, okay, do your initial design of experiments, and then for this next part, just to always skip any initialization and go straight into phase opt. I have to look into the code for that, though. So we're also getting 2 predictions. Again, no uncertainties, but that would be fairly easy to add from that covariance matrix. And then here, I'm glad I went through this multi-objective one. It does seem to be plotting showing the Pareto front in some sense. So the optimal trade-offs, but being that this particular parameter was the best one for response, the first response, and this one is the the best for response 2, and so it's just showing the two the points on the Pareto front. If I go here and do plot model, we'll see what happens for later. Okay, so we got those plots, and then we're getting response 2. Okay, so after doing plot model, it actually exposes a button called plot Pareto frontiers. So I'll give it a second. I'll also just note the fact that I had here 1.06 rather than 1.0. Something like this response is actually, I think, the in-sample predictions, though I'm not sure why it would have been 1.0 exactly in the previous case, but to me, at least, this would suggest it's in-sample predictions, not in-sample measured pieces being shown there. And then for the Pareto frontiers, I'm not sure if I did something wrong or not. If I go over predictions. Okay, so you're getting the 2 predicted responses, no uncertainty. Oh, okay. I don't know why exactly it hadn't popped up yet. Maybe I just needed to. Oh, yeah. Okay. It was showing as running. So I needed to just wait a little longer. Okay, then for this one, let's do. Yeah, it'd probably be best to zoom in. Looks like the uncertainty being plotted here is pretty huge. It might be nice to add something that allows that to be toggled on or off. But let's see, parameterization. Let's say I kind of like that they're using that terminology, parameterization for the runs. So I'm not sure if they use that language elsewhere for parameterization. So looks like I left this really big, or no, there's a pretty big gap. I'm also noticing there wasn't anything to specify thresholds on the objectives, which in my opinion is a pretty good way to do kind of incorporation of domain knowledge, asking the question if response is less, in the case we're minimizing, if response is greater than X, some number, it doesn't matter how good response 2 is. Generally, you need some level of domain knowledge to be able to say what X is, and that's something that can help the algorithm in adding a soft constraint on where it should be focused on. It's a nice Axe tutorial, the multi-objective Axe tutorial that kind of covers that in more detail. So if I go here, okay, response 2 is like 0 to 1 and -2 to 2. So maybe what I'm a bit confused about is I don't know, something seems a little strange here. First of all, parameterization 19. If I go back to my data, I only had, I think, about 10. Yeah, I only had 10 starting out with, and ran it for 1 prediction. So something seems a little off on this one. Also considering that the, saying here are the 2 best parameterizations. Anyway, maybe I'm missing something. Something obvious here. It kind of seems like these are clusters of the 2 points in some sense, and maybe it had already been, like, the responses had already been scaled. In other words, I'm not really seeing this 5-3 and 1-5 Pareto front being shown there. But and then generally with a Pareto front, it can be a little bit nicer to have lines, essentially like a line mapping what the Pareto front is. Now, this was 2 objectives, so I'm also kind of curious what happens if I add a third response. So I'll do the same thing, just kind of perturb the numbers a little bit. Probably would have been better if I had auto-calculated those, like stuck with the Brandon function maybe and auto-calculated those, so those giving something meaningful. I tend to use some of the ones here, these like kind of modifications on the Brandon function. So I'll do like some like sense of a multi-objective Brandon, and adding other kinds of constraints or variables there. So anyway, probably I would have, in retrospect, used something like this and give it real values instead of the randomly generated ones. I've always used scikit-learn sometimes to. Scikit-learn has some models like that. Yeah, they have like dummy regressor, and they also have a way to generate. Not dummy regressor, but they have a way to generate data sets. Yeah, like make classification, make regression. Cool. Yeah, generate a random regression problem, and then essentially you can tune it a little bit. There's a user guide around this. Anyway, this can be nice instead of just saying like, oh, let me throw random numbers in there. Let me make a problem that isn't real world, but it actually has some correlations there that can help you with showing the model. I'm not sure if that's shared that screen or if I'm only sharing this tab. But anyway, you can search for some of that for like scikit-learn. Okay, so past that, let me go in and add the data file once again. Looks like it only takes one file at a time, so make sure you don't add multiple. Let's see if I do try to add multiple files, what happens? So it looks like I can only, yeah, I think it only lets you add one file. So yeah, it's auto added these two as factors. So I need to go in, remove that, and I can add response 2. So we've got the three outputs there, and base ops. Say minimize for everything. The not a metric piece, I guess that's one where just is an outcome that still gets predicted. And so I'll come back to that one for the metric in a second. Okay, you can only optimize 2 metrics. The other outcomes need to be set to not a metric, and you can use them to define outcome constraints. Okay, so it does seem that in this setup, it's limiting to 2 objectives, like in a multi-objective optimization sense, to 2 objectives. I doubt that's due to constraints under the hood, and more so about the plotting or some, I guess, kind of imposed heuristic here, like, hey, don't throw in 10 objectives and try to do like 10 objective optimization. Instead, define outcomes and do an outcome constraint. So in other words, going back to that Pareto front plot, it won't allow you to generate that, or like that's a moot point because it doesn't let you do more than 2 objective optimization. Instead, it asks you to treat one of them as a metric and add an outcome constraint, which if I go here, yeah. Now these outcome constraints, these are also soft penalties because this outcome is black box as well, and so by putting some kind of constraint here, you are penalizing for things outside of that. And sometimes, one way to think about these optimization problems is like there's just a real world materials optimization task is a constrained optimization task, and you just have, like, let's say in a manufacturing setting, you just kind of need everything to be within some tolerances or constraints on everything, or above some threshold or below some threshold. So one way of looking at it, personally, I'd probably allow for multi-objective optimization for like a somewhat arbitrary number of outputs or outcomes, and then disable the Pareto frontier functionality, or like have a way that's showing it for only a few, kind of doing like a selection of here are the 2 out of all my objectives that I'm plotting for the Pareto front. I'll go ahead and do the compute update model here real quick. Okay, so we have, okay, so still on, some level the Pareto front being shown, at least, though again it's no longer optimizing for this, and it's only showing the 2 objectives here. That is kind of interesting. I'm not seeing anything here that uses the terminology objective. It's using response and saying whether to minimize or maximize a response. Personally, I think objective is pretty universal when it comes to Bayesian optimization, especially. Which I know. So plot model, update plots. Okay, so we have this response 3 response. So again, it's leaving out this. Not a metric. It's leaving out this outcome. Yes, it's using response, but metric, I guess, instead of objective for the terminology there. Then plot Pareto frontiers. Okay, so Pareto model is not fit on metric. So I'm assuming when doing this, okay, yeah, it looks like it is, yeah, acts under the Pareto utils. That because you specified response 2 as not a metric, somewhere in the code, the logic there, it's just throwing an error due to not fitting it on that. Maybe. Anyway, if we'd have to dig into that more, I'm sure that's just a simple fix for kind of like the plumbing and the logic there when you have 3 responses, or in this case, 2 what I'd call objectives and an outcome. Something about. Oh yeah, the original error message is redacted to prevent data leaks. Fair enough. So that's actually kind of nice that it gives you a traceback even, which I could then take and open on the on a repository, which I think I'll actually do right now. Open an issue with that message. And excuse me, this setup. Oh. And also attach that that file I've been using just to make it easier to reproduce. And so I guess one thing, it does look like it's allowing you to select between base opt and Sobel for the generator. Excuse me. I guess one kind of issue here when it comes to doing single suggestions of Sobel, it's a Sobel sequence, and to retain those space filling properties, you need to know what Sobel sequence it's a part of and kind of where along that sequence you are. It's not that you can't just suggest single points from a Sobel sequence. That's actually one of the appeals over Latin hypercube sampling, is that you can generate a Sobel sequence and then just kind of continue on that sequence, whereas the number of points in a Latin hypercube sampling are predetermined at the beginning. sort of thing. And then if you can't line up your Latin hypercube with the exact number that would be required, you can generate more Latin hypercube points, as in like you create a Latin hypercube design that's more than the number and you randomly sample within those. It was like Sobel versus Latin hypercube versus other methods. Some of them are a little more about how you're interacting with them, not just like how good they are at space filling. Or in other words, like how you interact with them, how that affects the space filling properties. So in this case, I don't see anything that allows you to specify like, hey, I generated these other points from a Sobel sequence. So it's just kind of saying, like you don't have, I guess like anything about like the random state of the Sobel generator. So in some sense, to me, this kind of reads as you will do Sobel technically, but that's just going to give you a random point because it's like a single point out of the arbitrary Sobel sequence at best. Hopefully it's not implemented in a way where you just kind of suggest the same Sobel point over and over again because you're like starting that Sobel sequence from scratch. That topic in particular is covered in I think there's an issue recently. I threw that in. Best practice. Anyway, not exactly sure where that was, but I think I had talked about that. Oh yeah, probably with the SQL. Yeah, probably here. So this one, when it comes to like the database in the background, like if you try to store the data independently of the initialized client, it can become a problem because you're essentially, if you want to get the Sobel sequence, those space filling properties preserved, then you would need to generate all of those and have the algorithm know that those are all part of kind of like the same sequence. In other words, going back to here, I think the separation of 1 and 2 can be kind of nice, saying to people, hey, generate your initial design, and then once you have some of those, switch over to Bayesian optimization. Don't worry about generating a ton of points there, but then it's a little bit, as I think about it more, I'm also a little bit surprised that they have Sobel here in the base opt part. So anyway, just something to think about with that one. But overall, seems pretty nice, pretty well featured. It would be good to see. One thing that would be really nice to see is just somebody going through this and running a campaign or several campaigns, I guess, had a number of different benchmark functions that we hosted at the Bayesian optimization hackathon for chemistry materials last year. You can see a bunch of those benchmarks here. And so, for example, like simplest one, the Brandon function, should start pretty quickly. Hopefully, this is one of those other ones, definitely more on the advanced optimization side of things. But as an example, here we go. Yeah, it's like Brandon function. This is kind of a nice way to just demo human in the loop because you've got this web app and you're essentially saying like, oh, let me go to the web app and do this, and that's as if I was performing the experiment outside of the regular optimization loop. And you take that and you hard code it back in to wherever you're storing your experimental history. So it would be nice to see something where somebody goes through this, maybe a little bit tutorial style, and generates the experiments for the Brandon function, or maybe the Hartman-6 function. Station benchmarks. Yeah, Hartman 4, Hartman 6. It's like maybe doing that for the Hartman-6 function, or Brandon, generating your Sobel sequence, going over to Bayesian optimization, running several loops, looking at the best so far optimization trace for that. And if you wanted to get a little bit more interesting, using some kind of like multi-objective output function. Okay, something personally I think would be great to see is this advanced optimization one being used. This encapsulates a lot of, like, this is a benchmark that I would say is fairly real world in terms of the characteristics, and there's more about this one, but essentially you have 23 hyperparameters, or like tunable variables, factors in the other language. 3 of those so 2 are Boolean, essentially one's categorical. There's even a fidelity parameter that kind of controls the cost. All of these are meaningful. Under that, it's a ML model tuning problem. There are 4 different outputs, and we even know have some like domain knowledge about how certain parameters are correlated with each other, as well as like objective thresholds on each of these. So something like that to kind of show, hey, here's a synthetic function, but we're not going to perform these in the lab. We'll just pretend like this other external app is us running the experiment. But cool, yeah, it looks like pretty nice tool that people can use.